I guess a career that I've had following those successes kept me in drug discovery, where I've always belonged and always been. At different levels of seniority, during and after different company mergers where business units were destroyed, people made redundant, new ones created, and somehow hung on in there. I'm not sure why, but perhaps because I was seen as slightly innovative, I could see things. But certainly creativity is something that fails more times than it succeeds. I think it's meant to, and I think you mustn't be afraid of failure. So that creativity is good. So that's probably why I hung on in areas which I didn't know very much about. Eventually the industrial career came to an end and went back to university. And it was clear that industry was still, as the whole biological scientific community was, still grappling with the unraveling of the human genome. This immense database of numbers that people had no idea what to do with them. In the past, if you wanted to select a drug target, you probably had 20 odd years of academic research teaching you where it was, what it did, what the side effects might have been. Now you picked up a genetic database and you had no idea. You didn't have that 20 years or so, whatever, of knowledge behind it. You had to create that and take flyers. So the great predictions that the human genome was going to transform science within a small number of years was wrong. It will, and it already is, but in the speed it was predicted, no. A major problem, as people get to understand this more and more, is translation of the science that comes from molecular biology, if you like, a transfected receptor into a host cell. You don't know if it's going to pick up the same characteristics as the native tissue. You don't know if the native tissue, which is usually going to be a rat or a lab animal, is the same as human. There are so many translational steps to get it right, and after all, we're making medicines for humans. So within the industry, it was very clear that translation was important, still is, and it's necessary to translate from molecular/animal to human. That is not easy, depending on the area. You can get blood, so if your target is there, that's fairly simple, relatively simple. But if it's brain or something different, that's much tougher. And it's an area, human tissue biology is an area that is not well done. Even today, and I've done this for various talks, you'll go to academic societies and count the number of presentations that involve native tissues, native human tissues, and they are in the single-digit %. If you take out the blood abstracts, presentations and talks, and let's face it, that's a bit easier to get, they are in the 1–2% of total. It's just not done. So back in university, we set up this lab to gather as much human tissues as we could. We did it in a way that, this is not me on my own, but we did it in a way that took work away from the clinicians, because they have a busy time, so that we taught ourselves how to consent patients, how to talk to pathologists, how to collect, and how to catalogue and understand the whole process. So we took it away from the clinicians, but worked with them. So to develop human tissues, so it's not the only way in which science is going, but an access and a greater understanding of the human, clearly important.